If you're over the age of 40 and taking creatine, there's one important detail that many people never hear about. Even though you're using the supplement, your body may not be getting the full benefit from it. The problem isn't that creatine doesn't work. In fact, it's one of the most thoroughly researched supplements available. Hundreds of studies have shown that it can help increase muscle strength, support brain health, improve physical performance, and may even help maintain a healthier metabolism while reducing body fat as we get older. The real issue is how your body uses it. Many people take creatine every day, but a significant amount never reaches the muscle cells where it's supposed to work. Instead, it stays in the bloodstream, gets filtered by the kidneys, and is eventually eliminated from the body. That means you could be paying for a supplement without receiving all of its potential benefits. So what does that look like in everyday life? You may notice stubborn belly fat that doesn't seem to respond no matter what you do. Your energy might fade long before the day is over. Maybe your memory isn't as sharp as it once was, and you occasionally walk into a room only to forget why you went there. Exercise may feel more difficult, recovery could take longer, and keeping your muscle mass becomes increasingly challenging. If any of that sounds familiar, stay with me. By the end of this video, you'll understand what may be holding creatine back from working effectively in your body, and you'll discover a few simple factors that research suggests can significantly improve how much of it your muscles actually retain. Before we dive into that, we need to correct one of the biggest myths surrounding creatine. For years, creatine has been promoted almost entirely as a supplement for bodybuilders, weightlifters, and serious athletes. Because of that, many people picture huge muscles, heavy lifting, and intense gym sessions whenever they hear the word creatine. Unfortunately, that image has caused many adults over 40, especially women, to ignore one of the most valuable nutrients for supporting healthy aging. The truth is that creatine does much more than help build muscle. Its main job is to support your body's energy production. Creatine helps regenerate ATP, which is the primary energy source every cell in your body depends on. Without ATP, your cells simply can't perform their normal functions. Your heart needs ATP to keep beating efficiently. Your brain relies on it for thinking, memory, and concentration. Your immune system depends on it to function properly. Even the process of breaking down stored body fat requires ATP to take place. This energy is produced inside tiny structures within your cells called mitochondria, often referred to as the body's powerhouses. Another fact that surprises many people is that around 95% of the body's creatine is stored inside skeletal muscles. The remaining amount is found in important organs and tissues, including the brain, heart, and nervous system. These are also some of the areas that become more vulnerable as we grow older. After the age of 40, natural creatine levels gradually begin to decline. Muscle mass slowly decreases through a process known as sarcopenia, while the mitochondria become less efficient at producing energy. As ATP production drops, several changes can begin to appear. Your metabolism may slow down, recovery after physical activity can take longer, strength may gradually decline, and mental sharpness isn't always what it used to be. Many people simply accept these changes as a normal part of aging. But in many cases, they're actually signs that the body's cells are producing less energy than they once did. Because of this, scientists studying healthy aging have become increasingly interested in creatine. Research continues to show its value for supporting muscle health, physical performance, and brain function. Some ongoing studies are even exploring whether creatine could help older adults experiencing age-related cognitive decline. So when I say you could be wasting creatine, I'm not just talking about missing out on better workouts. I'm talking about potentially losing the full benefits of one of the most promising compounds we have for maintaining strength, energy, mental performance, and overall health as we age. Now let's look at why this happens. A lot of people assume that once they swallow creatine, it automatically enters their muscle cells. But that's not how the body works. Muscle cells use specialized transport proteins to move creatine from the bloodstream into the cell. You can think of these transporters as security gates. Unless those gates are working properly, creatine can't get inside where it's needed most. And here's the detail that very few people are ever told. Those transport systems rely heavily on sodium. Yes, the same sodium that's naturally found in common table salt. This isn't just a theory or a health trend. It's a well-established principle of human physiology. The transport process that carries creatine into muscle cells depends on sodium-driven mechanisms. Without enough sodium available, those transporters don't work as efficiently, which means less creatine enters your muscles and more of it may simply pass through your body without being fully utilized. When sodium levels are low, this transport system doesn't work as efficiently. That means less creatine makes its way into your muscle cells, and more of it stays in the bloodstream instead of being stored where it can actually be used. What's surprising is that many adults unknowingly create the perfect conditions for poor creatine absorption. Think about a typical morning. You wake up and drink coffee. Then you exercise and lose fluids through sweat. You're trying to eat healthier, so you've cut back on salt. After that, you mix creatine with plain water, take it on an empty stomach, and you're already slightly dehydrated with low electrolyte levels. Later, you wonder why creatine doesn't seem to be making much of a difference. Research has consistently shown that the body's internal environment plays a major role in determining how much creatine is stored inside muscle tissue. One well-known study compared two groups of people taking the exact same amount of creatine. The only difference was that one group consumed it with carbohydrates, while the other took it by itself. The results were clear. The group that paired creatine with carbohydrates stored significantly more creatine in their muscles. Why did that happen? Because carbohydrates trigger the release of insulin, and insulin helps activate the cellular processes responsible for moving creatine into muscle cells. When healthy insulin signaling works together with adequate sodium levels, those transport systems become much more effective, allowing muscles to absorb and store more creatine. Several later studies found similar results. The takeaway is straightforward. The amount of creatine you take isn't the only thing that matters. The conditions inside your body when you take it are just as important. If you're swallowing creatine first thing in the morning while dehydrated and without nutrients that support its uptake, you may not be getting everything this supplement has to offer. Now let's talk about something many people don't associate with creatine: fat loss. Creatine isn't a stimulant. It won't speed up your heart rate like caffeine, and it doesn't produce that instant fat-burning feeling many weight loss products promise. Because of that, people have often assumed it has very little effect on body fat. But newer research tells a different story. Studies involving adults who perform resistance training have shown that those taking creatine frequently lose more body fat than participants taking a placebo, even when both groups follow similar exercise routines and eating habits. Other research reviews have also found modest yet meaningful reductions in body fat percentage when creatine is combined with regular strength training. So how can a supplement known for supporting muscle growth also influence fat loss? The first reason comes back to energy production. When your cells produce ATP more efficiently, your body's metabolism generally works better. Cells that have enough energy are better equipped to perform the countless tasks required to maintain a healthy metabolic system. Think of it like this. A cell that's running low on energy can't work at its full potential. A well-fueled cell can perform its job much more effectively. By helping restore ATP, creatine supports the body's entire energy production system. That doesn't make it a miracle fat-burning supplement, but it does mean it plays an important role in the metabolic processes that affect body composition, physical performance, and healthy aging. The second reason is one that surprises many researchers. In 2015, a study published by a research team associated with Harvard described what they called a feudal creatine cycle inside certain fat cells. Brown and beige fat are different from the white fat most people think about. Instead of mainly storing calories, these types of fat help burn energy to produce heat. Researchers found that creatine appears to support a recycling process inside these fat cells that increases mitochondrial activity and boosts energy expenditure. In simple terms, it encourages these specialized fat cells to burn more calories simply to maintain body heat. The researchers later tested this idea in animal studies by removing creatine activity specifically from fat tissue. The outcome was striking. Those animals gained more weight and developed signs of insulin resistance, even though they weren't eating more food. Their fat tissue simply became less effective at regulating energy use and temperature. So what does that mean? It suggests that creatine isn't only important for muscles, it also has an important role inside certain fat cells. When enough creatine is available, those cells appear to burn more energy. When creatine activity is reduced, that calorie-burning process becomes less efficient. The third reason involves the way your body manages blood sugar. A study published in Diabetes examined people whose legs were placed in a cast for 2 weeks, preventing normal movement. As expected, muscle activity declined. Researchers also found that levels of an important glucose transport protein, known as GLUT4, dropped by about 20% in the immobilized leg. During rehabilitation, participants were divided into 2 groups. One received creatine, while the other received a placebo. The results were impressive. The placebo group simply returned to normal levels. But the creatine group didn't stop there. Their GLUT4 levels increased to roughly 40% above where they had started. This suggests that creatine may help muscles absorb glucose from the bloodstream more efficiently. Improved glucose uptake can lead to better insulin sensitivity, fewer energy crashes throughout the day, and a steadier supply of fuel for your body's cells. And when your body handles glucose more efficiently, it's generally better at reducing unnecessary fat storage while maintaining more consistent energy use. Now here's the most important point of all. None of these potential benefits matter if creatine never makes it inside your cells. This is where many adults over 40 become frustrated. They're exercising consistently, making healthier food choices, and taking supplements, yet they still don't see the progress they expected. The missing piece often isn't effort, it's cellular energy. Every major system in your body depends on ATP. Burning fat, preserving muscle, thinking clearly, recovering after exercise, and maintaining healthy blood sugar all require a steady supply of cellular energy. As we get older, ATP production naturally begins to decline. The mitochondria become less efficient, muscle creatine stores gradually decrease, and even the brain has less energy available than it once did. So when someone says, "I can't seem to lose belly fat anymore, even though I'm eating better and exercising," it isn't always because they're lacking discipline. Sometimes, the real problem is that their cells simply don't have the energy they need to perform at their best. When your cells don't have enough available energy, your body becomes much more conservative with its fuel. Instead of freely releasing stored fat, it tries to hold on to those reserves. From a survival standpoint, that makes perfect sense. If the body believes energy is limited, preserving fat becomes a priority rather than burning it. This is where properly absorbed creatine can make a meaningful difference. Once creatine successfully enters your cells, it helps restore the systems responsible for producing energy. Muscle cells become more efficient, glucose is used more effectively, mitochondria generate ATP more efficiently, and even fat tissue can become more metabolically active. Over time, these improvements may gradually support healthier body composition. It's important to understand what creatine does and what it doesn't do. Creatine isn't a fat-burning supplement. It won't magically melt away body fat or act like a stimulant. Instead, it helps create the right internal environment for your body to produce energy more efficiently. When combined with regular exercise and a balanced diet, that improved energy production can better support fat loss over the long term. Now let's look at some of the most common mistakes people make when taking creatine. The first mistake is taking it first thing in the morning with only water on an empty stomach. After an entire night without drinking fluids, most people wake up slightly dehydrated. Sodium and other electrolytes are also lower than usual. Since creatine transport depends in part on these factors, your muscles may not be in the best condition to absorb it efficiently. The second mistake is taking creatine immediately after a workout, long run, or sauna session without replacing the fluids and electrolytes you've lost. At that point, your body is already depleted. Without restoring hydration and electrolyte balance, creatine may not be absorbed as effectively. Some people experience bloating or stomach discomfort afterward and assume creatine is to blame, when the real issue is that their body wasn't prepared to process it properly. Another common problem is choosing a poor quality product. Lower grade or non-micronized creatine powders often don't dissolve well in water. They can leave gritty residue, mix poorly, and sometimes cause digestive discomfort. Depending on manufacturing standards, lower quality products may also contain unwanted impurities. When absorption is poor or digestion becomes uncomfortable, many people assume creatine doesn't work, when the problem may actually be the quality of the product they purchased. The fourth mistake is ignoring hydration, electrolytes, and nutrition altogether. As we discussed earlier, healthy insulin signaling and adequate sodium help support creatine transport into muscle cells. That doesn't mean you need a high-carbohydrate diet, but staying properly hydrated and maintaining a healthy electrolyte balance can make a noticeable difference in how effectively creatine is utilized. The fifth mistake is simply not taking it consistently. Creatine doesn't work like caffeine. You won't feel an immediate burst of energy after a single serving. Instead, it gradually builds up inside your muscles over days and weeks. Missing doses regularly makes it harder for your muscles to reach and maintain optimal creatine stores. When poor timing, dehydration, inadequate electrolyte intake, inconsistent use, and low-quality supplements all come together, it's easy to understand why some people believe creatine doesn't work.